Hello everyone, myself Vedant Patil. I am going to give a short presentation on the topic soft object modeling and visual realism. So let's start. Introduction to soft object modeling. Soft object modeling is a crucial field in computer graphics focused on creating realistic, dynamic simulations of deformable and pliable objects, from clothing and fabric to jelly, slime, and other gelatinous substances. The ability to accurately model the complex behaviors and interactions of the soft materials is essential for achieving a visual realism in digital media. The introductory section will provide an overview of the key challenges and the techniques involved in soft object modeling, setting the stage for a deeper exploration of this fascinating domain. Now let's see the challenges in achieving visual realism. The first challenge is capturing the intricate deformation. Soft objects often exhibit intricate non-linear deformation that can be difficult to model accurately. From the suitable wrinkles and folds to the fabric undulations of gelatinous substances, replicating these complex behaviors requires advanced mathematical and computational techniques. The second challenge is handling collisions and interactions. Soft objects do not collide and react like rigid bodies. They become entangled, merge, or separate in intricate ways. Accurately measuring these complex interactions between soft objects as well as their interactions with the rigid environment, it is a significant challenge. The third challenge is achieving realistic shading and lighting. The unique optical properties of the soft materials such as transparency, subsurface scattering, and complex reflective behaviors can be difficult to capture throughout traditional rendering techniques. Developing robust shading and lighting models for soft object is an essential for achieving visual realism. Let's see the techniques for realistic deformation and shading. The first technique is deformation modeling. Advanced simulation techniques such as the use of mass spring system, finite element method, or position-based dynamics can accurately model the complex deformations of soft object. This approach considers the underlying physical properties of the material, allowing for realistic bending, stretching, and tearing behaviors. The second technique used is the surface tracking. To capture intrinsic surface details, techniques like mesh-based deformation, level set, or particle-based methods can be employed. This method dynamically updates the object surface geometry to reflect the changing shape and maintain the visual field during the simulation. The third technique used is the realistic shading. Specialized shading method such as the incorporating subsurface scattering and the complex reflection can produce the unique optical characteristics of the soft materials. By accurately stimulating the interaction of the light with the object surface and the interior, this shading technique enhances the overall realism of the rendered result. Now let's see the capturing subtle surface detail. First is the microgeometry modeling. Capturing the intricate surface detail of soft objects such as fine wrinkles, bumps, and textures can significantly enhance the visual realism of the stimulation. Techniques like displacement mapping, normal mapping, or procedural geometry generation can be employed to add these subtle surface details without increasing the computational complexity or the complexity of the course simulation. Second is the material appearance. The specific material properties of soft objects such as glossiness, transparency, or the subsurface scattering characteristic play a crucial role in the overall appearance. Accurately modeling these material attributes and incorporating them into the shading and rendering pipeline is essential for achieving a convincing and visual striking result. The third one is the dynamic texture mapping. As soft objects deform and interact with their environment, the appearance of this surface texture should be evolved dynamically. Techniques like texture coordinate deformation or procedural texture generation can help to maintain the coherence and realism of the object surface as it undergoes complex transformations during the stimulation. And the last one is the multi-scale representation, combining multiple levels of details from physically based stimulation to high resolution details can create a visually striking and computationally efficient representation of soft object. This multi-scale approach allows for the efficient simulation of large-scale deformation while preserving the visual richness of the object appearance. Now let's see the generating novel views and perspectives. The first one is the camera positioning. Strategically placing the camera to capture unique angles and perspectives of the soft object stimulation can dramatically enhance the visual interest and sense of immersion. Techniques like dynamic camera framing or stimulated camera movement can help to create a dynamic and engaging view of the deforming soft object. The second one is the lightning design. Carefully crafting the lighting setup, including the placement, intensity, and the light sources, can significantly impact the way of soft objects and perceived. Experimentation with different lighting configuration can help accentuate the unique properties of the soft material, such as their transparency or subsurface scattering effect. The third one is the artistic composition. Applying principles of visual composition such as the rule of thirds, leading lines, or focal points can help us to create a visually striking and aesthetically pleasing rendering of the soft object. Throughout framing and arrangement of this soft object within the sense can greatly enhance the overall impact and storytelling potential of the final result. Post-processing. The strategic use of the post-processing techniques such as color grading, depth of the field, or motion blur can further polish the refine the visual representation of the soft object stimulations. This adjustment can help to integrate the soft object seamlessly into a overall visual style and the atmosphere of the digital environment. Now let's see the integrating soft object with the rigid environment. First one is object interaction, ensuring that soft object realistically interact with the rigid environment, such as colliding with the surfaces, sliding along edges, or deforming around obstacles, is crucial for creating a cohesive and behavioral visual experience. Advanced collision handling and response algorithm are necessary to achieve these seamless interactions. Second one is the surface constraint. Soft object may need to be constrained or encroached to a specific point or surface within the rigid environment to maintain their desired positioning and behavior. Techniques like position-based constraint or dynamic attachment points can help to integrate the soft object with the surrounding scenes. And the last one is the shade, lighting, and shading. To fully integrate the soft object into a rigid environment, the lighting and shading models used for the soft and rigid components may be carefully coordinated. This ensures that the soft object naturally blends in with the overall lighting and material characteristics of the scenes, creating a cohesive and visually coherent result. And the last slide is of the conclusion and future directions. In this presentation, we have explored the fascinating field of the soft object modeling, highlighting the key features and challenges and techniques involved in achieving visual realistic simulations for capturing interested deformation and handling complex interaction, to leveraging physical based stimulation and integrating soft object with a rigid environment. The advancement in this domain have enabled increasingly sophisticated and immersive digital experience. Looking to the future, the continued development of soft object modeling promises even more remarkable feats of visual realism. Advanced in areas such as real-time, high-fidelity simulation, data-driven material, and the seamless integration of the soft object with the visual and augmented reality environment will undoubtedly push the boundaries of what it is possible in computer graphics and animation. And as this technology progresses, the ability to maintain truly lifelike and visual captivating soft object other stimulations will have become an even more integral part of creating engaging and immersive digital experience. Hope you have enjoyed. Thank you.